In this video, we are going to be going over the Geometry Semester 1 pre-assessment for the semester test. These questions are very similar to semester test questions that you may see, so what I encourage is that you take out a pencil and a paper, and maybe you could even write on your pre-assessment, but also maybe you want something else to kind of take notes on, or maybe draw on the sides of your paper, because I'm going to be giving out tips and tricks that you would want to use for the semester test, things you need to study, and things you need to remember before you get into that test. We're going to be going kind of at a quick pace because you should have a lot of this filled out already, and I'm not going to go over a lot of the algebra. I want to make it as quick as possible, so I'm just going to go through the processes that you're going to use in each problem. For the first one, it says we're trying to find the length of a segment with these two endpoints. That means we're going to use the distance formula. So as you can see, I've got the distance formula set up. And then one thing I wanted to mention was my students in the past have struggled with this problem on the semester test, and the main reason is because they do not label their points with x1, y1, and x2, y2. So if you don't do that, if you think you can do that in your head, that's fine, but I just wanted to put that out there that I have had some trouble with my students in the past with that. They've had some issues because once they set it up and they're trying to fill out the formula itself, they always find that they have some errors or something very simple could get messed up. So as you can see, I've already done that. I've got them highlighted there for you. And I just simplified the parentheses first, and I got 4 squared plus 4 squared, which basically means we will have 16 plus 16. And that's the exact same thing as letter C, which is the square root of 32. Okay, number 2. It says find the coordinates of the midpoint of a segment having these two endpoints. Again, I have these labeled x1, y1, x2, y2. I never really taught this with the formula. I did give it to you, but I've always kind of stated that it's really just the average of your x values and the average of your y values. So I did set it up with the formula, but negative 11 plus 0 divided by 2, that's a negative 5.5, or as they have in the answer in a fraction form, negative 11 over 2. And negative 4 plus negative 2 is negative 6, divided by 2 is negative 3, so A is my answer for number 2. Let's move on. Number 3, as you can see, we're going to use the segment addition postulate. Now it says in the question, let A be between B and C. If you do not draw a picture of this, you have a very likely chance of getting this wrong for a simple mistake or something like that. You have to draw it out, you have to label it, and then we can move into how to solve it. If it's segment addition postulate, I've always said take the two small segments, add them together, and it makes a big segment. So for this one, it'll be that 5x minus 20 plus the 4x minus the 25. Add these two things together, basically this piece and this piece, add them together. What are we going to get? We're going to get the entire thing, which I have labeled as 36. Now, once you solve for x, we don't want to just jump into our answer right away. We're going to actually have to plug that back in. If I plug that back into both the first two pieces, oops, I'm not on my highlighter. If I plug that into my first two pieces, this one there, and then that one there, I'm going to end up getting what I got for C, which is 25 and 11. Number 4. In the picture, QT bisects SQR. That's a big key. Whenever I see the word bisect in the question, that's huge. I actually stopped at that point, and I drew my markings. As you can see on my picture, I drew my markings where those two angles are congruent. Continuing, I just labeled the rest of it out there. It said RQS was 8a plus 16, which I accidentally erased apparently. So 8a plus 16, and then RQT was 6a minus 4, and then it said find QTS. So what we're trying to find is T to Q to S, which is basically just that one part of that angle. So this one we also said was 6a minus 4 because it bisects, and then we can just use the angle addition postulate. So the two small angles, 6a minus 4 plus 6a minus 4, will be equal to that 8a plus 16. And then again, you're just going to solve for a. I'm not going to go through that because I want to keep us moving. But write that down. If you are seeing this for the first time and you don't have this one solved, write that formula or write that equation down, and then you can solve it for yourself later as you're studying. I think what I ended up getting was a equals 6 when I solved that, which is another point I wanted to bring up, because if you're not careful, you could just circle 6 on the semester test and do everything right but still get the question wrong because you didn't finish reading the directions. The directions say to find TQS, not figure out what A is equal to. And after you plug that back into TQS, the 6A minus 4 there, you're going to end up getting 32 instead of 6. Number 5, it says if measure of BGC equals 6x plus 10 and measure of CGD equals 4x plus 12, find the measure of CGD. Okay, so basically what I did was I filled in those two pieces right there, and then what it's looking for is the entire angle, so those basically added together. Again, we're going to use the angle addition postulate on this. So we'll do 6x plus 10 plus the 4x plus 12. Now, where we could go wrong is people could think, oh, those look like they're relatively the same angle, and put those markings in there and say that they're congruent. Well, they're not. They're not congruent. They are, though, adding up to equal 90 degrees, as you can see by that little box. So we can say if we add those together and equal them to 90, we would be able to solve for x. Once you solve for x, I know you get some decimal. I can't remember what it is offhand right now, but you're going to have to plug that back in. Again, we're trying to find everything there. Oh, we're not trying to find everything. I made a mistake. Okay, so we're not trying to find everything. Good thing I checked again. It says CGD. We should always check before we submit our answers, but it's looking for just that angle. So I plugged it in for the 4x plus 12 to get D as my final answer. As you can see, I've already got the answers written down for the next problem here. First of all, we're just going to go through them. So WTN, W to T to N, that's right here, that angle. And then RNS. RNS is right there. So those are our two angles. I can look at both of those measures. One's 110 and the other one is 70. Those add up to 180, which would make those E supplementary angles. Next one, TUN. T to U to N is right there. RNS is right here. So 20 plus that 70, that's going to be 90, which would make those complementary angles. Next one, RNS and SNU. Looks to me like we've got a straight line that's formed with those angles, so that would make a linear pair. If you have two angles that are adjacent, meaning they share a wall and a vertex, and they're supplementary, that would be a good sign that you have a linear pair. Next one, VNT, right there, and TNU, TNU. Well, as you can see, they're not a linear pair because they're not making a very straight line, but they are still sharing a side and a vertex. Remember that vertex is right here. They're sharing that vertex. That means that they are adjacent angles. They're sharing that side and have a common vertex. Next, TNU. We're back to TNU and RNS. As you can see, my highlighter has made a perfect X with those angles, which can only mean those are vertical angles, or letter B. Let's continue to number 11. It says, which of the following statements is false? I didn't have to read far on this one because I saw the first one was false. It says AEB, which is this angle right here, and DEC, which is this one right here, are supplementary angles. Nowhere have we ever said that vertical angles are supplementary. They're always congruent. So A is obviously the incorrect answer. I will let you go through the other ones on your own. Those ones are all false though. Number 12, what property could prove? So this would be like a proof. So if this was our maybe one of our lines in our proof, this would be like the next line, and we're trying to figure out what they did. Well, as I look at it, I see we've got two of the same thing. We've got AB here, and we've got AB there. Those ABs are no longer found in our solution, so what did they do to get rid of them? It looks like since they added them, we would have to subtract them to get rid of them. So number 12 is D with the subtraction property. Number 13, what property would prove this? So measure of B is 100, and A plus B is 180, so that means if we substitute then the measure of A in, or I'm sorry, we're substituting that 100 in for B, then we're going to end up getting measure of angle A plus 100 equals 180. So that's the substitution property for that one. Number 14, it says find the measure of angle 3. This is actually a pretty easy question. Didn't make you solve anything too difficult on this, because if you look at only the top part, maybe I can just highlight the top part. What we have here are two parallel lines. One of our parallel lines is right here, the other one is here, which means our transversal would be this one. And since our 80 is right here and it's asking for angle 3, those are alternate interior angles. I know alternate interior angles are congruent. They both look acute, so that one will also have to be 80 degrees. Next one, it says find the measure of angle 13. Let me erase this quick. Okay, angle 13. I can see that's down at the bottom. Well, these are still our parallel lines. That's one of our parallel lines, that's the other. That's our transversal. It's trying to, it wants us to find 13. And what I notice is that 13, angle 13 there, is a corresponding angle with angle 5, which would make it 68 degrees. Now, where people could get confused is they could say, well, Mr. Anderson, isn't it also a corresponding angle up there with angle 9? Those are like corresponding angles, which they are technically, but they aren't parallel lines. P and Q aren't. So you can't go, you can't say 9 and 13 are going to be congruent because they're not paired, they're not on parallel lines. So for this one, the answer is 68. Number 16, let me zoom in. Number 16 here. It wants parallel, perpendicular, or neither. For this one, they are, as you can see, we're looking at our slopes. Our slopes are reciprocals, but they have to be also opposite reciprocals to be perpendicular. These ones are both negative, so this is neither. For number 17, here's what we have. That one's negative and that one's positive. That's a good sign. Also, it's a reciprocal. It's 3 over 2 in the first one. It's 2 over 3 in the second one. That means they're perpendicular. For number 18, it says 5x minus 2, and this one is 5x, and you could write like a 5x plus 0. It's the same thing. Our y-intercepts are different, but our slopes are the same. Therefore, those are parallel lines. And lastly, and I think this is probably one of the questions that I've had the most questions on so far, y equals 5 and x equals negative 3. I better get some room and draw what that looks like. So if this is my coordinate plane, and I'm going to draw 1, 2, 3, 4, 5, 6 lines on each axis. The line y equals 5, this first one here, that is a line going through the y-axis at 5. So 1, 2, 3, 4, 5. That would be a line that goes through the y-axis at 5 like that. X equals negative 3 is a line that goes through the x-axis at negative 3. So that one would look something like that. So if you have a perfectly horizontal line that goes through the y-axis and a perfectly vertical line that goes through the x-axis, then that would be two perpendicular lines. Let's move on to number 20. It says find the measure of angle 1. Now the orange ones I obviously filled in for you, but those weren't given to us. So the first one that I found was this 91 right there. How did I find that? Well, it's a linear pair with that 89. This makes a perfectly straight line under there. So all I had to do was take 89 minus 180, and I got 91. After that, I could find angle 1 pretty easily because now I've got 2 of the 3 angles inside a triangle. So I took 180 minus 91 minus 52, and I got 37 as my answer. After that, I could find that this was 53 because I know that this is a rectangle. And I know it's a rectangle because these are right angles. So that fourth one would also have to be a right angle, even though they're not showing it. And so once I got this 53, then I had the 89 already, and I could find angle 3 pretty easily by subtracting it from 180, subtracting the 53 and the 89 from 180, and I got 38 for that one. Number 22. It says solve for x given that AB is congruent to BC. Is the triangle equilateral? It says choose the best answer. Well, the way that I would figure this out, if I'm trying to figure out if this one was equal to this one is, or no, it says solve for x so that they are equal. So we're finding which x value would make them equal. To do that, we're going to set them equal to each other. So 2x minus 1 equals x plus 4. Again, I'm not going to solve this for you, but I did end up getting the same thing. I plugged it back in. I think it was 5, x equals 5. So I plugged in a 5 there, so 5 plus 4 gave me 9. And then I plugged in a 5 there as well, and I got, obviously, 10 minus 1 is 9. So all of those sides are 9, which means it is equilateral, and I selected A, yes, because all of the sides are congruent. Number 23, the measure of angle B is blank. If I zoom into this picture a little bit, obviously the oranges I filled in again. I found the 51st by, again, seeing that this is a straight line. That's the first thing I always look for. Are there straight lines? Because if they are, you know you can subtract from 180. So 180 minus 130 gave me 50. This is supposed to be a right angle symbol. It looked like kind of a weird one, but it is a right angle symbol. So if this is 50 and this is 90, then this would have to be 40. Okay? So then, after that, I couldn't really do anything else because I don't know what this is, that angle B there, so I had to move on to the other side. Obviously, this one would be 90 because it's perpendicular. So if I had 90 and 51, I could subtract those from 180, and I got 39. So then, now the last step that I had to see here was, this is a straight line right there. I should make that smaller so you can see what I'm talking about. Okay, this is a straight line. So basically all of this stuff has to add up to 180. So the 40, the 39, and then whatever B is, all have to add up to 180. That must be 101. Okay, next one. Okay, these questions. You will see these on the semester test. Determine which congruence postulate or theorem proves the triangle is congruent. So we're looking for congruence here. Again, our 4 ways to do that. Well, we've got 5 technically. But our SAS, well, I guess they're already listed for us. These are basically our 4. And then there's also the HL theorem, but it's not providing that as an option. So there's no way that we're going to be able to circle that one anyway. Side, side, side. I picked side, side, side for this one because we had 2 of the sides already, but with the reflexive property, we could get that 3rd side, and we can show congruence with that. For number 25, I see reflexive again, so there will be obviously a side in my answer, but we also have this angle, and then since that's a right angle, that one also is a right angle, so those are congruent. So basically, we've got 2 sides in an angle. Now, the only thing that you'd have to worry about is it that one or that one? Because, oh, I'm sorry, we only have one side in an angle. I'll take that back. We only have one side in an angle, so it would be this one or this one. one side and two angles. Okay, so which one is it? Well, if you're choosing this one, what you're saying there is that the side is between the two angles, and it's not. We would have to show that this one is congruent down at the bottom if we wanted to prove that. Our side is right there, and it's outside of our two angles, so it's got to be letter D. Number 26. I see we've got congruent. That's what these symbols are. But we've also got parallel, because you can see those arrows. So if we have congruent and parallel, that means, and I've said this before, if you have parallel lines on these triangle proofs, it's probably going to be alternate interior angles. So the only thing you got to do next is figure out which angles are the alternate interior angles. Alternate interior angles both have to be touching one of the parallel sides. I'm going to restate that because that's very important. Alternate interior angles, and any of those angles that you're talking about, whether they're exterior, interior, corresponding, whatever they are, they each have to touch a parallel side. That's why the angles would have to be there and there. Let me show you what I mean would be incorrect that a lot of people do all the time. They would say this one and this one are alternate interior angles because they look like they're alternating our transversal. This is our transversal right there. But are they touching a parallel side? No. They're touching this side, which isn't parallel, and then they're touching that side, which isn't parallel either. So those are obviously wrong. It's got to be these two right there. Then we've also got the reflexive property, which I'm going to mark twice to show that that's different. So what do we have? We have a side, an angle, and another side, which would be why I circled or highlighted A. Moving on to number 27. I see reflexive property right off the bat, and that's the only thing I really need. I've got angles on this side of it and on the other side, so it would be angle, side, angle. It says find the measure of the exterior angle. I don't know if you guys remember this one, but the exterior angle theorem stated that if I add these two together, those are remote interior angles. If I add them together, they equal the exterior angle. So all I had to do was do x plus 65 equals 2x plus 10. Solve for x. Once I find x, I've got to plug it back in because it wants us to find the exterior angle. And obviously I got 120 or letter D for that. We've got our proof now, number 29 through 31 here. Looking at this picture, I see I've got parallel lines. Now this goes back to the same problem we were just talking about where our alternate interior angles have to touch the parallel lines. So it's going to be this one right there, and it's going to be that one right there. Those are my alternate interior angles. Then for number 29, I can basically look to see which ones those are, and that was letter C. Then I also have the reflexive property, which is obviously for number 30, what I circled. And then what I have is a side, an angle, and a side. So number 31 was B. Number 32, in the figure shown, it says that BC is parallel to DE. So these two were parallel. It says AB is 7, BD is 14, and BC is 8. Find DE. All right, so this is kind of tricky. Oh, and I didn't even write an answer for this. I must not have done it. So we can do it together. I have to set up a proportion for this. Where people are going to get this confused is this the mid segment? Problems that we've been working on in the past. No, because it does not say in the question. Let's read the question again. Does it say anywhere that there's like midpoints or anything like that? Or bisecting? No, it doesn't. So we can't use mid-segment and just say, oh, this must be 16. Especially since this is 7 and this is 14. A lot of students will try to just say, well, that must be doubled too. It's not. Here's how we would set this up. So for the little triangle, ABC, just this triangle right away, I'm going to set up a proportion. It'd be the length of the left side, which is 7, over the length of the bottom, which is 8. That's going to be equal to, let me change colors. If I'm looking at my big triangle now, the length of the left-hand side, which in this case is not 14, it's not 7, but together it's 21. And the bottom is x. So let me pull out my calculator. And so what we're going to do is cross multiply and divide. So we'll get 8 times 21 equals 7 times x. So 8 times 21 is 168. Divide both sides by 7. So 168 divided by 7 is 24. So x equals 24, which means this side, it has a length of 24. Looks like that's letter B. Next one, you can see how similar these two triangles look. Do not get them confused on the semester test. This one says we've got two midpoints. It's saying that Q and S are both midpoints. Those right there are midpoints. That's when we can use the mid segment. The only problem is this one's not so easy with that. So if I'm setting this up, I basically have to say, okay, two QS's are going to make a PT. So x plus 7, if I multiply that by 2, I would have to distribute that. That's going to be equal to that 5x plus 5. Solve for x. It's not asking for what x is, though. It's asking for PT. So once you find x, you're going to have to plug it in right there. Looks like I ended up getting 20 for my answer. Number 34. This one is determining how you, determining which similarity postulate or theorem proves the triangle similar. Obviously, I have vertical angles on this, and I'm just trying to prove similarity, which these are your three ways to show similarity, side, side, side. Remember, these are not the same as the other ones we were doing. These ones are proportions. We'll get into that here in a second, but angle, angle is the answer for this one, and here's why. I've got my vertical angles, and then I've got parallel lines. If I have parallel lines, that means I must have alternate interior angles. Well, let's see if I can. So if that's one of my parallel lines and that's my other one, this could be my transversal going through them, which means those would be my, I better put 2 markings on them. Those would be my alternate interior angles. You could also do these as your alternate interior angles too, though, if this was your transversal. So basically, we have 3 angles showing these 2 triangles are showing that all 3 of their angles are congruent. We don't need all 3, we only need 2. Number 35. This one I chose side, side, side similarity. And as you can see, I've got my proportion written out below. I basically looked for the biggest sides of the triangle first, the 30 over 15. Then I stuck with the 26 over 13 and then 26 over 13, and I set them all equal to each other. Do those all equal the same thing? Yes. They're all 2 over 1, or just a 2. So they all have a scale factor of 2, which means my answer is B, because they were all the same. Number 36. On this one, I see we have an angle and a side. We don't have anything else. We don't have anything else that we could prove. So basically, that's it. Well, we don't have anything here that says just a side and just one angle. So that one has to be a none. And by the way, these 2 triangles don't even look similar. So you should look at that on the semester test too. Could be a giveaway. Number 37. This one I said was side, angle, side. We obviously have 2 right angles, so those angles are congruent. And the 28 goes with the 14, so 28 over 14 and 10 over 5. Again, those are both a scale factor of 2, so it's side, angle, side, because those proportions were the same. Moving on to writing some rules and drawing some images here. It says translate the figure using the rule. This is a translation. We're going to move it to the right 2 because it's x plus 2, and then we're going to go down 4. So everything moved to the right 2 and down 4, to the right 2 and down 4, to the right 2 and down 4, and that's what my picture looked like. For the next one, it says rotate the figure 90 degrees clockwise. This is important. This is something that I would say everybody should write down right now. So if the video needs to be paused, we can pause the video and make sure everybody has these written down. These need to be memorized for the semester test if you plan to get this question correct. Okay, if the video is paused, great. We're going to continue now. And I have to look at what it's asking for. It wants it 90 degrees clockwise. We don't have clockwise. We only have counterclockwise. What does that mean? That means we have to use a different one. We're not going to use this 90 degrees because that's counterclockwise. 90 degrees clockwise means I got to have it end up in this quadrant right there. Well, that's really 270 degrees counterclockwise. So we're going to end up using that one. I've already got my points listed, as you can see. This rule says you're going to make your y value go first, and the x is going to become the opposite. So for these, maybe I'll just write them down first. At the top, it's going to be 8, -4, 5, -5, and 4, -1. Those are where all the new ones are going to go. So 8, -4, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4 is right there. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 is right there. And then 4, -1, 1, 2, 3, 4, -1 is right there. And I can connect these points and have a rotation of 270 degrees counterclockwise or 90 degrees clockwise, however you want to look at it. Last one. Oh, no, not the last one. Number 40, reflect the image over x equals -1. This is the line, and if you don't know what this line looks like, you're not going to get this right. Like I said, x equals -1 is a line that goes through the x-axis at -1. As you can see, I've got it as a dotted line in orange on my graph. Then every single point, since this one was 2 away, that one would have to be 2 away. Since this one is 5 away, it has to be 5 away on the other side. And this one is 1, 2, 3, 4, 5, 6 away. So this one would also have to be 6 away. They're all the same amount away from that dotted line. So that's how you would reflect it. Number 41, last one. As you can see, I've got the same rules written down. It says we want to rotate 180 degrees and then reflect it over the x-axis. Okay. Also, it says we're just looking for basically one point, vertex D. So this is the one that we're looking for right there. So, I mean, for me, do I have to even draw the whole picture? Or can I just reflect and rotate that one point? I don't see a reason to reflect the whole thing and go through all that work. If I just want to do that one point, let's just do that. So if I'm rotating that one point 180 degrees, well, we're going to use this rule. -x, -y. So take that 5, 5 and make it a -5, -5. Looks like it's right there. And I'm going to call that D prime because that's the second generation of it. Then it says it wants us to reflect it across the x-axis. So 1, 2, 3, 4, 5 away from the x-axis. So if I go 5 away the other side, 1, 2, 3, 4, 5, it's going to end up right there. This is my D double prime, my second generation. This point is -5, 5, and I believe that is letter B. We didn't even have to reflect the whole picture, so looking for things like that can be a real shortcut for you on the semester test. Last couple things I'm going to say here. make sure you draw pictures. If you're not drawing pictures, and I know a lot of these, they're going to give you pictures, so you're not going to really have to worry about it too much. But if it doesn't give you a picture, like at the top here for this number 3, if you're not drawing this picture, you're going to struggle. Draw pictures, fill in, label things. If they do give you a picture, do what I did. I'm drawing and coloring on every single picture. If you want to bring colored pencils for the semester test, you sure can. We've got crayons in the classroom, but I think colored pencils might be better. If you want to use those things, you can use them. Nothing's going to hold you back from that. So, again, study from this. This is the most important thing that you can probably study from for the semester test. If you're understanding this review, you're going to do just fine on the semester test. That's all I have for you. Thank you for watching, and good luck on your